We are going to start new topic, that is lubrication system and its design process. Okay, so let us look at that. So in the third semester you have learned about the lubrication systems. So in this we will study about the what do you mean by lubrication system, what are its types, how it works, and some related 2 3 problems. Okay, so these problems you will have to write down on the practical book. So first of all, I will re-explain lubrication system. So in machine or moving parts, there will be different types of motions, actions. Due to the rubbing actions, rolling actions, there will be generated of friction, and due to this friction, the part of machinery get heated and cause wear action. So to avoid this, there will be a thin film of oil is incorporated in between these two parts, so that the friction will be avoided, and this thin film separate the two layers and act as a lubricants. So different types of lubricants. First one is a splash type lubricant. So this type of lubrication system is dipper is provided at the bottom end of the connecting rod, and lubricating oil is kept in an oil pan at the bottom of engine. The dipper provided with the connecting rod end scoop the oil during each revolution when it enters the oil pan. The splash is produced due to rotation of the crankshaft in the oil pan. The splash oil mist form in the crankcase housing lubricate the main bearing, crankshaft bearing, timing gear, push rod, cylinder liner, valves, etc. However, the valve mechanism is lubricated with the help of oil can manually at regular interval. So this type of lubrication system is generally provided in single cylinder engine with closed crankcase. So it is generally provided in single cylinder engine having a closed crankcase. Next system is a 4-speed lubrication system. The 4-speed lubrication system mainly consists of sump, gear pump, oil filter, drill oil passes through moving parts, and main pressure gauge. So here there is a diagram. So in this diagram, this system is already taught in the third semester. I will just revise it. So this is a engine assembly. Engine assembly. This is a bypass valve. This is a oil sump. This is a stainer. This is a oil cooler. This is a recent technology. This is the oil cooler also. It will like a radiators of the water cooling system. And these are the sumps galleries. This is the upper portion. This is the oil pressure gauge which measure the gauge of the oils. These are the galleries inside the crankshaft. So oil from the stainer it sucks and it can be transferred through this bypass valve to the first galleries. Then it is passes to the holes of the crankshaft. There is a crankshaft. There are internal galleries. It can then transfer and lubricate the crankshaft bearing and connecting rods. After that, there is a gallery in the connecting rod, and it can lubricate the connecting. There is oil rings. Through oil rings, it can be lubricated to the wall of the cylinders. Later on, it can be passed to the secondary gallery. From the secondary gallery, it can be passed to the camshaft. It is located on the upper side. Valves, spring or rocker arm if present. The remaining oil is deep. It can be transferred from the return galleries to the oil pans. And there is a one pump. This is called as oil pump. This oil pump is not shown in the figure, but this oil pump is drawn by the crankshaft gear. And this oil pressure exert pressure of the oil. This pressure is get exceed. This bypass valve get opens, and the supply of oil transfer through the first and second galleries. When the pressure drop downs, the bypass valve get closed, and supply of oil is again transferred from first gallery to second gallery. So this is the mechanism which are already taught in the third semester with neat diagrams, and I have shown this physically also. Okay, so there is a one gear pump which is provided. This oil pump is a gear type pump, internal gear type pump. It is driven by crankshaft and is draw the oil from sump through the core mesh filter and discharge into the distribution network that is drill passes of the crankshaft and crankshaft. The pump force into the oil all the crankshaft and connecting rod bearing and timing gears. It can lubricate the cylinder wall, piston pin and small end bearing and connecting rod are lubricated by oil coming from the ring, a big end bearing through holes drills to the connecting rod. Surplus oil then flows back to the sump. This also washes the external impurities, wear road product, bearings and clearance between the mated parts. From the camshaft, the oil pressure goes to the valve mechanism, rocker arms, shafts. Excess oil from the cylinder head is received back to the crankcase through the push rod. An oil pressure gauge is fitted with the system to indicate the lubricating oil in the system. This is oil pressure gauge. The amount of oil crankcase depend on the volume of crankcase, filters, duct, and consumption of oil through the operations. Then the specific capacity of diesel engine should be range of 0.14 to 0.21 liter per kilowatt, and for dry sump 0.15 to 0.70 liter per kilowatt. This is the specific capacity of diesel engine. Next, what do you mean by crankcase breather? So crankcase breather means it is provided in the engine sump to remove the fuel and water dilution of oil due to condensation of oil and mixing of diesel. As a result, injector dribbling as well as permit the escape of gases to the atmosphere which can be blown into the engine sump by the pistons. The crankcase breather म्हणजे इथे एक तुम्हाला कॉम्पोनंट दिसतो क्रँकरेस ब्रीदर म्हणतात. त्याचं फंक्शन काय आहे की क्रँकरेसमध्ये जे हीट जनरेट होते ते हीट जसं आता तुमचं इंजिन आहे ते इंजिन तुमचं कूलिंग झालेलं आहे ऑइलच्या थ्रू, तर ते हीट तुमच्या क्रँकरेसमध्ये क्रँककेस इज अ पॅक केसिंग and heat is generated inside the crankcase. So for escaping that heat, there is one unit is attached. It is also called as crankcase breather. So excessive heat from the crankcase is escaped from this unit, and also it can remove the fuel and water dilution. So water dilution is caused due to condensations. It can mix with the fuel, so it can be removed with the help of this component is called as crankcase breather. The gaseous mesh forces the crankcase oil to pass the main bearing seal and engine gasket by rupturing them. Small air cleaner is commonly provided in the crankcase breather to prevent the dirt and dust particle from air entering into the crankcase breather. Crankcase breather वर एक फिल्टर लावलेलं असते की बाहेरून येणारे इम्प्युरिटीज आतमध्ये गेल्या नाही पाहिजे आणि याच्यामधले जे गॅसेस आहेत ते क्रँकेस ब्रीदर मधून बाहेर पडतात. एवढंच त्याचं फंक्शन आहे. Oil filter keep the oil free from dirt, dust and any abrasive type foreign materials. It collect in the inside the engine sumps. So commonly coarse and fine filters are used with tap practice 30-60 to 0.5 to 1 micron respectively. The wire slit plate and wire gauge filter with 60 micron mesh are used for coarse cleanings. The function of oil filter. What is the function of oil filter? Or oil flow rate through the filter depend upon surface area of the filter, size of the orifice, oil pressure, resistance to oil, viscosity, temperatures. Okay. Washable type oil filter and replaceable type oil filter. There are two types of oil filters. They are also known as metal plate or S type metal filters. This can be wire gauge type, S type or centrifugal type. It can be washable type filter, and another is a replaceable type filter. So you can observe in the diagrams, it is a replaceable type filter here. Filtering material is made up of cotton waste, paper, and perforated cover type papers. Plated resin immigrated papers can be also used when surface area can be increased by plating the papers. These are changed after 120 hours of engine operations. 120 hours पर्यंत हे चालते. It can be replaced. Okay. Next is the oil pumps. So oil pumps in the force lubrication system is Internal gear type. This is the internal gear type pumps. It's called as oil pumps. So lubricating oil is circulated in the system with the help of external meshing gear pumps. So sorry, this is the external type gear pumps. So pump shaft. This is a shaft. One shaft is attached to the gear. This is called as a driving gear, and another shaft is attached to the gear is called a driven gear. So this driving gear, there is one pulley here, and this pulley is attached to the crankshaft, and with the help of this crankshaft, this driving gear rotated, and as the driving gear rotated, this driving gear also rotated, and both are rotated in opposite direction. Suppose you can look at this arrow. This driving gear located in anti-clockwise directions. So driving gear located at rotated clockwise directions. Okay, as the oil is sucks from this section, it can be distributed like this. Here it like this, and it can goes through the outputs. So in this way, the oil from the oil pan is transferred to the upper galleries through these internal gear pumps. Okay. त्याच्यानंतर the pump shaft generally rotate at 4000 to 5000 rpm. This shaft is rotate to 4000 to 5000 rpm per minute, and the gear ratio between the camshaft and the pump is 1.0 to 1s.5. Next, the velocity of the gear pump should not exceed 10 meter per second. So its velocity should be in a range of 10 meter per second. Okay. Next is the quantity of oil feed to the crankshaft bearing is 60 to 70% of oil pump in the line. Next is the amount of oil delivered to the crankshaft and the valve mechanism. So these are some points. The required output of gear type pump depend upon. This is the output of pump depend upon these factors. Oil required for cooling of piston, crown, and lubricate the cylinder liner. So what do you mean by piston crown? Piston crown म्हणजे कोणता पोर्शन पिस्टनचा? कोणी सांगू शकेल? What do you mean by crown of piston? To the account of wear and tear in the pump gear with use. So this is the general portions. This is the oil pump. Next topic we have to. This is the most important topic. The quantity of oil pumped by the gear pumps. Quantity of oil pumped by the gear pumps. So this is a general theoretical portion. It can be asked as a theory question in your exam. Next topic is design related topics. So quantity of oil pumped by the gear pumps. So how much quantity of oil pumped by the gear pumps? So there is one derivation regarding that.